Now let's look at the same figure from an earlier example and see what happens to the coordinates when we rotate the figure 90 degrees counterclockwise. We're going to write down the coordinates for both the pre-image and image and see if we can determine a pattern. What are we going to notice? So let's first start off by writing the coordinates of our original points. Point A is at -4, 6. So we're at -4, 6. Point B is at -1, 6. Point C is at -2, 2. Point D is at -5, 2. Okay, so now let's look at from point A to point A prime. So if we draw our line segment to the origin and then back out to point A prime, we can clearly see that we have this 90-degree angle here. And let's write the coordinates for A prime. They are -6, -4. Okay, now let's look at point B. So point B goes here and B prime is here. Again, we can see the 90-degree counterclockwise angle that's forming here. And point B prime has the coordinates of -6, -1. Point C prime has the coordinates -2, -2. And the coordinates of D prime are -2, -5. So we go from -4, 6 to -6, -4. We go from B, -1, 6 to -6, -1. C, we're going from -2, 2 to C prime, -2, -2. And then D, we're at -5, 2, and we went to -2, -5. Well, I started to see a pattern as I started writing, especially after I got the second one done. Notice these X and Y coordinates, it looks like they switch spots, like -4, 6. You switch the 6 and 4 around and it looks like the first coordinate is now negative, whereas all the rest stayed the same. So we're going from X, Y. We are switching the X and Y terms around, because notice the -4 goes second, here the -1 goes second. And then the original Y coordinates were all positive, and now those are negative or getting their signs changed. So this is the pattern that occurs with 90-degree counterclockwise rotations. So as we see on this slide, the solutions that we had are indeed the same. And what we found is that when rotated 90 degrees counterclockwise about the origin, the X coordinate is the opposite of the pre-image Y coordinate, and the Y coordinate is the same as the pre-image X coordinate. Or in other words, or written symbolically, X, Y is going to -Y, X. What happens to the coordinates of a figure in a 180-degree rotation? And let's write down the coordinates of the pre-image and image to see their relationship and to see if we can come up with a general formula to help with these transformations. So let's start off with our original coordinates. Coordinate for point A is at -7, 5. B is at -1, 5. C is at -2, 1. And D is at -6, 1. And what we can see is if I go to the origin from, say, point A first, and then I continue to A prime, it shows a straight angle or a 180-degree rotation. We can do the same thing from B to B prime. If we go to the origin and then down to B prime, we have this, looks like a straight line through, or a straight angle. Same with point C and point D to D prime. We get a straight angle each time. So we can clearly see that this is a 180-degree rotation about the origin. And when this happens, we see that A prime has the coordinates 7, -5. And B prime has the coordinates of 1, -5. And C prime has the coordinates of 2, -1. And the coordinates of D prime are 6, -1. What do you notice between A and A prime, B and B prime, C and C prime, and D and D prime? Well, the coordinates look as though the numbers stay in the same order. But notice instead of -7, it's +7. Instead of -1, it's +1. Instead of -2, it's +2. So instead of X, it's actually the opposite of X. And then from 5 to -5 and 1 to -1, we're doing the opposite of Y as well. So the X and Y coordinates share the same numerical component, but their signs become the opposite of one another, one being rotated 180 degrees about the origin. So what we found in terms of a 180-degree rotation is that the pre-image coordinates become the opposite in the image, both the X and Y. We went from negatives to positives, and we went from positives to negatives. So when rotated 180 degrees, the X coordinate is the opposite of the pre-image X coordinate, and the Y coordinate is also the opposite of the pre-image Y coordinate. And our general formula or rule that we could write is X comma Y goes to -X comma -Y. What happens to the coordinates in a 90 degrees clockwise rotation? We're going to start by writing down the coordinates of both the pre-image and image, and then we're going to look for a similarity between each set and see if we can come up with a general formula. So let's start by writing the coordinates of our original points, A, B, C, and D. So the coordinates for point A are 2, 5. Coordinates for point B are 4, 9. Coordinates for point C are 6, 5. And the coordinates of point D are 4, 1. Okay, so now we're going to go to our primes. So for A prime, or our image points, we have 5, -2. For B prime, we have 9, -4. For C prime, we have 5, -6. And for D prime, I think, I'm not going to examine it, it's going to be 1, -4. And it is 1, -4. So I started to see a pattern, and I used it to get my coordinates for point D prime here. Notice 2, 5, they switch. and then it looks like the second number becomes negative. So we are going from x comma y to the x and y coordinates switch. So we have y and an x, and then the new y coordinate, or the original x coordinate, becomes the opposite. So our formula here is from xy, it goes to y negative x, or in words, the x and y coordinates switch places with the new y coordinate being the negative of the original x coordinate. So again, here are the coordinates of our pre-image and image, and we found that when rotating 90 degrees clockwise, the x coordinate is the same as the pre-image y coordinate, and the y coordinate of the image point is the opposite of the pre-image x coordinate. Or in other words, it goes from xy to y negative x. Let's try to summarize what happens to the coordinates during a rotation. When it was a 90-degree counterclockwise rotation, we went from having coordinates x, y to, well, the x and y values switched, and the new x coordinate, or the original y coordinate, became negative. In a 180-degree rotation, we went from xy to negative x, negative y, because it would say start in quadrant 2, and it would go 180 degrees straight through and come over here. So the signs would be the opposite in this new point here. In our first one, I'm going to draw that graph. If we started over here and we went 90 degrees counterclockwise, it would produce a point that would appear somewhere around here. We know that y and x, or x and y, switch positions, but then the original y coordinate that would be positive in quadrant 2 becomes negative when moved to quadrant 3. And then for a 90-degree clockwise rotation, we originally had something in quadrant 1, and it was making a 90-degree angle and coming down here into quadrant 4. And we noticed that the x and y coordinates switched places first, so we have y, x, but then because we are now in quadrant 4, this value became negative, or became the opposite. And wherever you are in a 90-degree clockwise rotation, this new y coordinate will become its opposite of the original x coordinate. And yes, in a 90-degree counterclockwise rotation, the original x and y coordinates became the opposite of y, comma, the original x. For 180-degree rotation, the x and y values stayed in the same position, but their signs became the opposite. In a 90-degree clockwise rotation, we went from xy to y, comma, negative x, meaning the x and y values switch positions, and the new y coordinate is the opposite of the original x coordinate.